Hi everyone, welcome to ICPC. Today we will walk through a Codeforces problem in this 2025 Rayan contest. So here is the problem statement. Darius wisdom. So you are given n columns, and every time you can move one stone to another column if the difference between the number of the columns is 1. And you need to achieve a non-decreasing order of the columns. Let us give an example. The starting columns have the configuration of 0, 2, 0, 1. So every move, and your target is to shift it into non-decreasing order. That is 0, 0, 1, 2 to make it non-decreasing. And how to achieve this? You can see that you can shift one stone from 2 to 1. So the first move is shift one stone from 2 to 1 because their difference is exactly 1. This will give us 0, 1, 0, 2. And now what's the next step we can make? We can shift this column to its adjacent neighbor, since the difference between the stones is 1. So shift the stone here, we get 0, 0, 1, 2. So in 2 moves, we achieved the non-decreasing order. Now the question asks, given this configuration, produce a sequence of moves within n steps that sort the columns into non-decreasing order. So we want to produce a sequence of moves with n steps or less. Let's give a more interesting example. Example 2. 2, 0, 2, 0, 1. So what is the target distribution? Target is, we wanted the 0 to be in the front, and 1 in the middle, and 2 to the right. 0, 0, 1, 2, 2, right? However, another valid configuration can be alternative 0, 1, 1, 1, 2. So moving a 1 stone from 2 to this column, since as long as it's decreasing, non-decreasing, it will be an invalid answer. What is the initial heuristic you might think of to solve this problem? So my initial idea was was changing the values. For example, when seeing the example, we want to change this 2 into 0, and then change this 2 into 0 using a value-based method, because this 2, we can decrease its value to 1 instead of, and we can also decrease it to 0. However, that is not the correct approach. So we don't want to think in the way to decrease each value into some desired values. However, what is the correct approach? Think about this way. Think in terms of reordering these columns. So we don't want to change this 2 into a 1 and another 1, but we want to move the 2's to the right and 0 to the left and 1 in the middle. Therefore, this idea of shifting instead of reducing each element is the key. And I will leave it a few seconds for you to think how we can sort this array into a non-decreasing order by using exchanges or transfers with just one at a time. The idea is shift the columns whereas we don't want to change the numbers. Shift the columns, that's the correct idea. All right, let's begin with the solution. Now we have the mindset of moving the stones. So just reordering them, what will the target goal be? Is it just find a destination distribution and then move the stones accordingly? So still using this example, 2, 0, 2, 0, 1. We want the target distribution to be all the zeros at the front, the 1 in the middle, and all the 2's at the right. How about let's give a more complex example. 2, 0, 2, 2, 1, 0, 0, 0. Now, what is the target distribution we want to achieve? Isn't it the zeros in the front? So 3 zeros in the front, 1 single 1 in the middle, and 2 2's in the end. Now, a good thing is we see there are 3 regions, and we can say this is region 0, and this is region 1, and this is region 2. And now we can see within this region 0 how we can get the incorrect values out of here. So now we see we need to remove the 2's from this region, remove the 1 from here, and in region 1 we want to remove 1, we want to remove 0 out, and in the region 2 we also want to remove the zeros out. So, how to achieve this? We can use a data structure called value in position, such as data structure. Value in position. Let's call it VIP, shall we? Then the first column we will say it's a value, and the second is the region. So position just means region here. Each of those value, region and value will contain an indices, all the indices. We need to remove. That means in the region 0, for value 2, we need to remove, let's give them the indices 0, 1, 2, 3, 4, 5. Region, for example, for the value of 2, region of 0, we see we need to remove the first and the second elements. So the indices to remove are 0 and 1. So those first two. Also in region 0, for value of 1, what are the indices we need to remove? Just 2, right? This element. So those are indices, index 2, region 0, region. And now, can you guess for region 0, the value of 0, what are the indices we need to remove? It's just empty, right? Because we don't have nothing to remove in the region 0. Using this data structure, what can we achieve? Let's first walk through the idea. Isn't that if we fix the region 0 and then we fix the region 2, we are done, right? Fixing region 0 means changing all of these above values into zeros. And fixing region 2 means we will change the 0, 0 into 2, 2. So after fixing 0 and 2, we are done. Therefore, the algorithm is as follows. Fix region 0, then fix region 2. Now it becomes how to write the fix function. Intuitively, to fix region 0, if the element to throw out is a 2, we first need to find a 1 to receive the value, right? And then we need to find a, and then it becomes 1, we need to find a 0 to change it to 0. Okay, let's write the algorithm. So for fix a certain region, how to write this function? We need to move all the elements out until they are fixed. So what should the outer loop be? Shouldn't it be a while loop? That's right. So using a while loop, while there are ones or twos in this region, one in region, well, there's one in region, so let's define the function to be fixed region X. In this way, we can fix any region by passing in whether it's region 0 or region 1. So while 1 in region, X, let's just use region 0 in this case. Fix region 0. So while 1 in the region 0 or 2 in region 0. Let's first fix 2. Since 2 give us the most headache. So if there are 2 that exist in this region 0, if 2 in region 0, a practice for you is to think how to generalize this into region X. Do you think it's correct that if the region is X, here we just say 2 minus X? So if the region, the X is 2, we will first remove 0 because it's the worst thing to exist, and it needs 2 steps. And how do we throw out 2? Let's find a 1. But in what region should we find the 1 at first? Shouldn't we want to find a 1 in region 2? Or region 1? If not, we will find a 1 in the first region. This is because we don't want to shift 2 a stone in here, shifting within this region 0, right? That doesn't make sense. So we want to get the 2 out into whether region 2 or region 1. So let's first find a 1 in the region 2. That is, we want to throw those 2's out to the last region, so it will save us time. If so, we can produce a swap. Next, so if there's no else, if we didn't find the 1 in the last region, we will just take the little worst choice to find a 1 in the middle region. Find 1 in middle region. Let's call it the right region. To make it more general. And else we can, if we find one, swap. We can swap. So this means if there are 2 in the region 0, we will first make the 2 into a 1. However, we see here there are no 2s out there. There are no 1s in region 1 or region 2. So let's skip this step and fix 1 first. Now fix 1. So removing the 1s out of the region. So let's find the 0 in region 1 because we want to move 1 into the correct region. So the first step is find 0 in region 1. If so, we can swap. If not, find a 0 in region 2. In this example, when fixing the 1, first check region 1. Is there a 0 here? Yes, there is a 0. So we will perform swapping this and this and causing it to become 1 and 0. This produces, this executes this first step. Is it clear? Let's walk through the entire example to make it more live. So how to walk through this algorithm in real time? Let's still use this example. 2, 2, 1, 0, 0, 0, and the target region 0, region 1, and region 2. So is the goal clear? We want to move the 3 zeros into the first region, 1 in the middle, and 2 in the right region. And how to produce the sequence of moves? We will use the fix algorithm in the right, and we will fix the 0 region first. First check, there are no, we want to fix 2, but there are no valid 1s in region 1 or region 2. So let's fix the 1 first, as we did before. So fix 1, we shift 1 into region 1. We got 2, 2, 0, 1, 0, 0. Nice. So here we fix the index 2. Fix index 2. Now let's check the region again. In region 0, we have 2, 2, 0. So we still have 2 things to fix. Now let's fix this one. the algorithm will use this data structure to detect that there are still remaining incorrect elements in this region. To fix the 2, fix index 0. We will first find a 1, right? This is region 0, region 1. So first we'll find the 1. Here we found a 1 in the middle region. Although we checked the last region first, we didn't find a 1. So we change it with the middle one. This is executing this step. So the first step is this, second step here, first, second. Make it a little straight. Now let's find the 1. Oh, awesome, we found 1. So we shift the 2 over there. This produce 1, 2, 0, and this 1 gets another stone. It becomes 2, 0, 0. So here, this is the region 0. Now what's the next step? Shouldn't we fix 1? Third step, fix 1. Fix this 1, so still fix index 0. We need to find a 0. We will scan the last region first and produce a swap. So this step 3 is finding a 0 in the third region, in region 2. So this is step 3. We produce a swap here. It becomes 0, 2, 0, 2, 1, 0. All right, we only have last one element to fix. Fix index 1. This element. It still requires 2 steps because it's a 2. So first find 1. Bingo, there's a 1 in the third region, so we shift the stones there. 0, 1, 0, 2, 2. And the fifth step, the fourth step is using which one of the algorithm, which line. So fix 2 and fix to become a 1. This is region 2. So in the right region. Here is our step 4. So step 4 is executing this swap here. Okay, we are almost done. What's the last index to fix? Still index 1, right? And we need to find a 2. Find a 0 to remove the 1. So this is region 0. How to find a 0? Okay, we found 1. So we shift it over there and produce 0, 0, 2, 2, 1. Shifting 1 to the right. Which algorithm, which line are we executing? We find a 0 in the third region. So we are executing this step. So the fifth step is still this swap. Now region 0 is fixed. This is what algorithm does it count as? It is a greedy algorithm, right? We always we fix 2 at first and then fix 1. And the key is using this data structure to keep the time complexity in O (n). Because every time we just check each region whether there are indices remaining there. And when producing the swap, we just remove an index from one of the rows into another row. So every time we pop from the back of the array and insert it to the back of the target array. All the operations are O(1). So the swap is an O(1) operation. So after fixing the first region, what should we do? Isn't that we will fix the this region, and then we are done. Now this is the Rayan contest, Darius wisdom problem on Codeforces. Thank you for watching.